I'm pleased to introduce Max Kreminski, who is currently a PhD candidate at University of California, Santa Cruz. And Max, along with James Ryan, one of our previous speakers, is one of the foremost names in sort of emergent storytelling, building on this idea of generate a lot of content and find the good parts in that content, and has done a lot of really cool stuff with story sifting. Many of us in the research community are following Max's work with great excitement, and Max, thank you for being here today. Please take it away.
Thanks, Stephen. So yeah, I'm going to be kind of doing, I guess, like a high-level overview of recent work in story sifting, focused on my own stuff, but then also talking about other people's stuff a little bit. I think you've all read the Felt paper, I think, for this class, and then maybe some of the bad news papers. So I'm going to be referencing those a couple times, but then focusing mostly on, like, I don't know, interesting applications of story sifting and sort of what you can do with it as a technology. Okay, cool. So there's my, yeah. Basically I'm going to go over like what is story sifting, talk a little bit about Felt, then talk about some of these like sort of application areas like egocentric story sifting, where you have like characters do story sifting themselves as part of the simulation, and then mixed initiative sifting, where you turn sifting over to the player as part of play, and then some authoring tools support work, which is Synthesifter, which sort of like synthesizes story sifting patterns for you based on examples you provided of stories that you find interesting, and then some interesting directions for future work if you want to get involved in story sifting as a research direction, basically. So first off, what is story sifting? I think you might be familiar with this already, but the basic idea is that in emergent narrative, where you've got sort of these bottom-up simulations that sort of produce stories through just having characters sort of wander around and interact with one another in interesting ways, you've got this sort of problem of sort of both these stories that emerge being interesting, right, and novel, and often sort of like having all these different kinds of actions and characters in them, but then also of overwhelm. So some of the classic examples of sort of emergent narrative games are things like Crusader Kings 2 or Dwarf Fortress, where you've got just like dozens or hundreds of characters wandering around doing things. There's all these different actions they can perform. There's all these different sort of like facets of the game world state that are evolving over time. And there's just so much for players to keep track of. And so you end up with these like very elaborate interfaces, where you've got like, here's all of the characters in this sort of Crusader Kings world, and here's all the sort of relationships to one another, or like all the different realms or vassals or religions and cultures they're involved in. And then like, here's all the different things my dwarves can do in Dwarf Fortress. And it's just like sort of this total flood of information. There's so much going on that it's hard to filter it down and find like the stuff that sort of makes for the interesting narratives that come out of these worlds. And so the sort of pain of emergent narrative, depending on whether you're my advisor, Michael Mateus, or whether you're me, you could critique it as possibly it's just one damn thing after another. So there's sort of all these events happening. They're not sort of obviously narratively related or narratively structured in any way. Or if you're me, you could say everything happens so much is sort of the essential pain of emergent narrative. Basically that like, if you allow these simulations to run, they'll just keep on generating content and events forever and forever and forever until you end up with this total situation of overwhelm, and there's no like sort of easy way to parse this out and find what is narratively interesting about it. And so the idea of story sifting is, what if we could develop computational systems that are capable of helping you sort of sift down to just the essence or just the interesting sort of narrative bits of all these different things that are happening in these worlds. And sort of James Ryan's approach to curation is sort of the work that introduced this idea, basically. So you've got the idea is that you've got this sort of like high-level curationist architecture, where the thing that you take as the simulated, the thing that you take as the story itself is not the simulated story world where all this stuff is going on, or not even, in fact, the chronicle, which is the list of all the events that have happened. What it is the stuff that is sort of produced by this sort of sifting process of first like winnowing down the events that have happened in the chronicle to a manageable subset that are somehow interesting or interrelated, and then using that as narrative material, which you feed to a narrativizer to produce the actual story. So this sort of lengthy process of curation is what produces stories, and not just simulations running wild on their own. And so for the purposes of this talk, we're going to be focusing mostly on the story sifting box here. And one of the ideas of this diagram is that every role here, every sort of like sort of hard-cornered box, can be played by either a computer system or a human, or a computer system and a human working in tandem. And that leads to some interesting possibilities for sort of human-centric or sort of mixed initiative story sifting that we're going to talk about in a little bit. But the essential idea is the same in all these different instantiations of this architecture. So story sifting, you've got all these events, you take a subset that are interesting to you, and you sort of form a story about them, sort of a narrative kernel almost. So you can see here we've got an example of like a character A starts a project, decides the project isn't any good, gives up on it. A second character B comes along and talks to them about the project several times in a row. And then finally A decides to resume work on the project. And you can imagine a whole bunch of different sort of possible ways of parsing these same events to get different sort of micro stories or subplots out of them, basically. And in order to have the system perform this kind of matching of these event sequences, what you need are story sifting patterns, or just sifting patterns for short. And these are basically specifications of groups of interrelated events that make for good or compelling narrative building blocks in some way. And because you want the systems that you're building to be able to recognize like a wide array of stories, a diversity of stories that are possible of emerging, you want to have a lot of these different sifting patterns in your library, right? So ideally, what we actually need is to make these as easy for humans to author as possible, because when you're sort of like faced with the problem of generating lots and lots of different sifting patterns to make stories that are interesting and diverse, you need to be able to like have the system be able to recognize a lot of different kinds of stories that can happen. And so this is really just another instantiation of the authoring problem, which you might be familiar with already. So felt is sort of an approach to answering this difficulty of authoring lots and lots of sifting patterns. The idea is to do sort of story sifting via this declarative domain-specific query language, which desugars to data log ultimately. And so what it looks like is kind of like this. I think you've seen maybe this exact example in the paper. But what we're saying with the sifting pattern is we've got an event sequence of two events, event A and event B, where the first event has the event type betray. The second event also has the same event type. We've got a character, care, and so the question mark before a symbol here denotes basically this is a logic variable to which a value will be bound through the process of running this query. And then the second event, event B, has the same actor. So both of these betrayals were perpetrated by the same person. We check that this person has the trait of impulsive, and then we've got this sort of complicated not join clause down here at the bottom, which is basically saying, okay, we've got these two events, event A and event B. Make sure that there's not a third event, event mid, between them, that was also perpetrated by the same character. So basically make sure this character hasn't done anything else between these two betrayals. And so the essence of all of this is two betrayals perpetrated by a single impulsive character who hasn't done anything else in between. And this is like a moderately complicated example of what a felt sifting pattern kind of tends to look like. And so all of this is implemented in terms of DataScript, which is the library that basically implements a particular flavor of data log for JavaScript and for ClojureScript. And so some of these syntax constructs that you see coming through here are Lispy, because ultimately this is written in a Lisp and it's using a Lisp parser on the back end. And then also things like this not join clause are pretty directly imported from the syntax of this DataScript library, like sort of its built-in flavor of data log. And so in the future, one of the things that we'd like to do is to come up with a better, more human-friendly syntax for authoring these kinds of things, where it's clear sort of what parts of the sifting pattern are related to one another, and where this not join syntax in particular is less thorny. So that's one of the things that I'm working on right now. And like, you can imagine different languages that desugar to this as sort of an output format, but this is the sort of like most raw or most low-level felt formalism that there is. And you can compare this to things like James Ryan's Sheldon sifting system, where he does all the sifting patterns as procedural Python code, basically. So you can see here that we've got like a candidate event that we're testing against a bunch of different conditions. So things like, is the event's name setfire, and is the ancestor of this event, or is one of the ancestors of this event in sort of the causal chain, where causal bookkeeping is sort of essential to James's approach to story sifting. Is there like a hatch revenge scheme somewhere in the causal chain of this event, basically? So is this essentially an act of arson committed as sort of an act of revenge against someone? And then we do a sort of some variable binding along the way. And if we find a match for this sort of top level part of this sifting pattern, where we're looking for a candidate that has sort of these initial traits about it, then we do a bunch of additional variable binding to grab different parts of the game state that are relevant to this this sort of arson revenge subplot, and sort of bind them all to different logic variables that we can then use later on. And in this case, that's just like sort of Python state changes. And the nice thing about felt is that, or one of the nice things about felt is that you have sort of this declarative formalism, which means that your binding of variables and your execution of the sort of like walking of the graph happens at the same time, right? So you just sort of describe what it is that you want. And this is sort of a sort of form of that same sifting pattern expressed as felt. And so you sort of do the binding and the traversal of this game state at the same time. So in this case, we've got like an arson event where the event type is set fire. The actor is the arsonist character. We have this sort of contributing cause data log rule that we've defined, where like an event can be sort of recursively in the ancestry tree of another event, based on like, did this thing cause this thing, and so on down the line. And then like your swear revenge event is sort of the thing that we're looking for as an ancestor. It's got to be of the type hatch revenge scheme. And then the actor for that has to be the same arsonist. So ultimately, like expressing the same idea, but more compactly in sort of this declarative formalism that the computer is also better at understanding. And because these are easy to parse and sort of easy to generate, we can do some interesting things where the computer sort of like automatically analyzes and modifies these sifting patterns and even generates new ones, but we'll get to that in a second. One of the interesting applications of this is egocentric sifting, where you have sort of characters themselves do the sifting, right? Or bring the sifting into the story world. It's a thing the characters can do. And one of the natural ways to express this is sort of as an implementation of character subjectivity via story sifting. So in this case, you've got on the left some sort of ground truth events that have happened, sort of things that have already taken place in the sort of complicated simulated story world. And we've got two characters here. Let's call them Izzy and Nicole. And each of them has a library of different story sifting patterns that they can apply to these events as a way of making sense of the world so far. So they can do things like pull out, here's 3 events that are of interest to me, basically, based on the sort of library of sifting patterns I've got at my disposal. And you can imagine that there are different sort of things influencing like which sifting patterns you give to a character. So for instance, a character might be sort of focused specifically on events that included them in some way or that are sort of like relevant to them directly, but they might also be focused on like, oh, this character is pessimistic. Therefore, they've got a bunch of sifting patterns that enable them to like look at the world and go, oh, this is a bad thing and it's going to lead to further bad things down the line. Versus an optimistic character might do the opposite. So in this case, you can imagine that Izzy is like having trouble doing some grad school thing and says, wow, I'm so bad at this, Nicole must hate me. And like maybe Nicole is their project partner on some grad school project or whatever. And Nicole is meanwhile looking at that and going, Izzy does so many cool things, I wonder if they'll be my friend. And sort of the divergent interpretations of these same ground truth events lead to so much possible emergent drama, right? And this sort of bringing sifting into the story world as a way for characters to sort of procedurally form disagreements with one another or sort of divergent interpretations as a driver of conflict can be a really interesting way to sort of build these simulations where characters are disagreeing about things that have happened and sort of interpreting the game world in different ways. And so what you can do implementation-wise is pretty straightforwardly bring a sifting pattern into your action definitions as part of the preconditions. So here we've got that same arson revenge scheme sort of sifting pattern as before as part of the when clause or the preconditions of an action. And we also introduced this one new precondition of like, okay, let's say this sort of arson revenge scheme is played out. And then there's also some bystander who has been harmed by something that the person who is the victim of the revenge scheme has done at some point in the past. And because this person is like, oh, wow, that person who just sort of burned down that person's barn or whatever got revenge on them for me. They're really cool. And the person who like was sort of mean to me in the past and then had the barn burned down, that person is a jerk. And sort of in the sort of effects of this action, we further modify the game state to include things like characters forming judgments of other characters. So in this case, the bystander can sort of form judgments of the characters that were involved in this arson revenge scheme. And this looks pretty much...
Sorry, do you mind if I just jump in with a quick question?
Yeah.
So this is happening while the simulation is running, right? So the characters are sifting as the events are happening, and then that potentially is changing how the simulation runs, right?
Exactly, yeah. So
Nice.
One of the neat things about Felt, like sort of as a system, is that it tries to integrate sort of sifting directly into this action definition scheme. So it provides like you a way to easily define actions that include sifting patterns as preconditions, basically. And sort of you can use it as dually, both a sifting engine only or as a sifting plus simulation engine, where characters are like themselves doing story sifting all the time.
That's so cool.
And so you might be familiar with similar looking formalisms if you've been doing a lot of planning work, which I imagine you have, where basically planning actions are defined in a very similar way with the preconditions and the actions. And so you can imagine doing planning type things to these.
Well, yes, I would say, so certainly this like precondition and effects setup feels very familiar to the planning thing, but what this does really well that the planning stuff struggles with is it's really hard to measure the like meta properties of a story via planning. Like you can specify the preconditions like these characters are alive and at this location and that kind of stuff, but it's really hard to talk about these properties of like something harmful happened in the past or even to talk about like the causal ancestors of events, like anything that is outside of just what's captured by the current state. is hard to specify as a precondition. And so I feel like that's a real strength of this system.
Yeah, and I think one of the ways that we get around that problem is by basically whenever an event happens, we commit it to the database as a bunch of new sort of statements about the game state. So the game state like kind of blows up as you do this, right? Like when an action is performed, we commit it as like 5 or 6 different statements every time. And so that's what allows us to do this like sort of interesting data log inference rule reasoning over what's happened in the past.
Okay, yeah. So I
yeah.
guess, right. I guess we could do that in planning too if we also were willing to kind of blow up the state. But I feel like the emergent storytelling systems, because they scale better in general, are more prepared to handle that explosion.
That's the hope anyway. So yeah, then and you can sort of see that like the definition of these actions is sort of, again, a human authoring thing. And ideally we can make these sifting patterns as easy to author as possible on the basis of like, we want to be able to author lots of these different actions to get a diversity of stories that are possible in the world. So this is basically a restatement of all the stuff that I've just said, but we have this sort of additional interesting division between internal and external actions the characters can perform in a lot of these story worlds we're working on. So like internal actions are things where characters basically use sifting to look at the state of the world so far, like what's happened in the past, and sort of form judgments or impressions of other characters based on that, or even motivation tokens is what we tend to call them. And then these motivation tokens are sort of consumed by external actions, which are characters sort of like reflecting on the, or like once they've reflected on the game world state and formed a motivation, they can then sort of operationalize that motivation in a variety of different ways. So a character who's like sort of seen this revenge scheme play out might go, oh, I need to do something nice for this person who got revenge on my like enemy for me. And then when they form that motivation, there's a whole bunch of nice things they can do in response later on, like bake them a cake or like, I don't know, etc. And you can sort of see some examples of these here. So like a character can resolve to get revenge on a character who keeps doing mean things to them, or like resolve to be nicer to a character who's having a bad day. And these two like first ones can be manifestations of the exact same events, but being interpreted in different ways based on different sifting patterns. Or a character can decide that like a different character Q is unreliable because they keep breaking their promises, or judge that like a professor who said negative things about 3 different research projects is like just sort of inherently hard to please. And then external actions based on those might be things like, oh, I think this person's mean to me all the time, so I'm going to sabotage their experiment. Or I think they're having a bad day, so I should probably bake them a cake. Or you can tell a character that a different character shouldn't be trusted because they're flaky. You can do things like exert only minimal effort while working on a character's project because they're going to be disappointed anyway, because they're always disappointed. That's just who they are as a person. And so this division sort of helps you, I think, sort of conceptualize the difference between like actions that are primarily about reflecting on the world state and primarily about sort of operationalizing like sort of changes to that in various ways. And we built this game called Cozy Mystery Construction Kit. It's sort of a collaborative storytelling game where we do what we call motivation arbitrage, where characters sort of start out with these initial sort of like minor annoyance type motivations towards one another, like, oh, you left the door open, and I don't like that because it means that my like lab animals might escape or whatever, versus like later on you get to the point where these characters are so agitated with one another that like one of them commits a murder basically, and then the rest of the game is sort of a murder mystery, like working backward from like how did this happen and then working forward to like how does this get resolved. And this motivation arbitrage thing is based on basically characters seeing the same events and having different interpretations of the severity or the importance of those events. So you can sort of like build up from these like tiny little motivations to these much bigger motivations as you go. So yeah, another interesting application of story sifting is this mixed initiative sifting stuff. And this is like, we started to do this in Cozy Mystery Construction Kit, but sort of went more in that direction later on. So the motivation here is actually sort of best, I think, exemplified by Bad News. I don't know how familiar you are with this one. I think you read one of the papers based on the syllabus, but the idea is there's like sort of an improv theater situation going on basically, where you've got a simulated story world of a small American town. You've got Ben Samuel on the right-hand side of this partition here, who is an improv actor who's basically portraying a succession of characters from this town in sort of live interactions with the participants. And the participants have been sort of tasked with identifying the next of kin of someone in this town who has died. And so they're sort of interacting with Ben Samuel as he portrays like a whole bunch of different characters in this town. And they're trying to get sort of information out of him about sort of like that character's relationships, that character's sort of like knowledge of the world state and stuff like that, so that they can identify the person they need to finally deliver the bad news to. And on the left-hand side of this partition, we've got James, who's sitting at his console with a display that looks kind of like the thing on the left. And he's actually typing out procedural Python code to perform sifting about like this character, about the state of the world, stuff like that. And this manual sifting that he's doing is basically like used to surface interesting information, and then he passes it over to Ben via this two-way communication channel they've got going on in the background. So essentially what's going on here is that James is doing live sifting using like just writing Python code on the fly, basically. And this sifting is sort of what enables Ben to portray these characters adequately. And so wouldn't it be great, right, if we could have James like doing this sort of thing, but actually he's a computer system and we don't need James to be like pinned to a desk doing it the whole time. And that's sort of the motivation for some of these mixed initiative sifting applications. Can we have a computer system do some of this work of pulling out the interesting stories that are sort of emergent in this world and surfacing them to the player, or to like maybe the actor who's trying to portray like these different characters as leads, basically, as sort of directions the story could possibly go. And so we've tried to build a game called Why We Like This. This is sort of still a work in progress, so it's not like done or released really yet. But the idea is that we provide sort of players with sifting tools, like the story world investigator in particular at the bottom, that let the player sort of make use of sifting to make sense of what's going on in these complicated story worlds. And sort of as they're telling a story, like they're sort of picking actions for characters to perform, which are filtered partially by what the characters are motivated to do, also partially by these author goals that you've got, where they're sort of like choosing, oh, we want to do things like involve Bella in the plot or escalate progress versus order. But these author goals themselves are inspired by sifting patterns, right? So the players are using this story world investigator at the bottom to look through, here's all the different characters in the world, here's all the projects they're working on, here's the relationships between these characters. And then there's these interesting tabs called situations and events, which both allow you to basically apply sifting patterns to the history of everything that's happened so far and sort of find leads like, oh, it looks like this pattern of events between these characters might be the beginnings of like a love triangle emerging, right? And so then you as the player can sort of choose to like make the development of that love triangle an author goal. And then the system will start surfacing actions that are relevant to developing that plot line further. Or you could alternatively choose to be like, oh, it looks like there's sort of an escalating cycle of revenge between these two characters. Let's try and make that a core part of our story and sort of work that into our author goals. This is the thing that we want to develop further. And the idea is that the system can then sort of like start picking actions to suggest to the players that are both in line with the character motivations, but then also that somehow advance these author goals that the players have picked out as like, I want this sifting pattern to be sort of more completely matched than it is currently. And then one of the things that we've done is sort of build some authoring support for authoring lots and lots of different story sifting patterns quickly. And that's called Synthesifter. It's this tool that basically applies well, I'll get to that in a second. The idea is that basically you can just point at some examples of the kinds of microstories you want to match and let the computer write the code that actually does the matching of them, which is program synthesis. It's kind of hard in the typical formulation, but this is actually a narrower problem called inductive logic programming, where the specific goal of what you're trying to do is to synthesize a logic program, for instance, a felt sifting pattern that correctly distinguishes between like positive and negative examples that the user has provided. And so this is like easy enough to do because the properties of event sequences are actually pretty straightforwardly mapped to the different clauses of a felt sifting pattern. So like if we are trying to do some baseball commentary thing, for instance, we might want to match examples of like a weak hitter who's performing unusually well, but then fumbles at a pivotal moment. In order to do that, we first need to define concepts of like what is a weak hitter and what is a pivotal moment the computer can understand. And so what we do is we define some data log inference rules that include things like, oh, a player is a weak hitter if they're a member of a team's lineup and their batting stat is like 2 stars or less. And then a game event might be pivotal if it's both an attempted hit and there's a runner on third base, or something like that, right? And you can define these concepts in any number of different ways. But the idea is that you provide the system with a bunch of these different rules that they can use to sort of make inferences about story examples. And then you let the player sort of pick out both examples, or the user pick out examples of both like, here are stories that are essentially the same thing. Like these are all examples of that kind of pattern I want to match. And then also to pick out negative examples of like, here are things that are sort of similar looking, but that I don't actually want to match, where they're like, they differ from that pattern in some key way. And because you provide these examples, you can sort of generate these properties of these examples. So things like the first event in the sequence has the tag swing and hit. The batter for the first event and the second event of the sequence are the same character, or like the batter for this third event is weak in terms of those inference rules we defined earlier. And you generate all of the properties for all of these examples, both positive and negative. using a bunch of different property generation strategies, which I'm going to gloss over, and sort of end up with this table basically of for every example that has been specified by the users, this story has these properties, this story has these properties, and then you can check which properties hold across the board for all of the positive examples and none of the negative examples, and translate those pretty directly into a felt sifting pattern, right? So something like this, where you take your sort of properties that you've detected as being common to all of your input examples and translate them into code. And sometimes you end up with things like an extra, like a clause that is not sort of like actually essential to the definition of the sifting pattern. But that's okay, because ideally your users understand the sort of generated code well enough that they can like go in and manually edit the sifting pattern to maybe modify it lightly to remove sort of clauses that aren't actually relevant to what they're trying to express. So in this case, you might have like the happenstance situation of, in all the positive examples we saw, the pitcher for the first event was always the same person, but that doesn't actually matter for the purposes of defining this particular sifting pattern. So we just manually omit that clause. And then you end up with the sifting pattern that looks kind of like this, and you can then sort of apply these to like all the normal things you would apply sifting patterns to. And we have an interface that we built for doing this that looks kind of like this. You've got like a scrolling filterable log of all the events that have happened on the left. You've got sort of an interface for specifying and selecting positive examples. Based on these positive examples, the system generates a sifting pattern for you. Then you can look at sort of possible additional matches for the sifting pattern and say either, yes, this is sort of what I'm looking for, or no, this is not what I'm looking for. And then as you sort of adjust these examples by adding more positive and negative ones, the system sort of refines its idea of what you're looking for and produces a more sort of refined version of that sifting pattern for you to mess with. So yeah, in the future, there's a couple of interesting directions that might be worth exploring. There's actually more too, but these are the ones that stand out to me as most obvious. One of them is the development of sifting heuristics, which are sort of these higher level rules that guide the system towards more storyful event sequences. And this is a thing that some of James's students are currently working on as of, like, I asked him a couple of weeks ago, and that is currently a line of research for them. And one of the things that might be worth trying here is trying to automatically identify which sifting pattern matches are like common versus uncommon, or sort of which sifting pattern matches commonly happen like together, for instance. So like, does this sifting pattern statistically tend to match like very often or relatively infrequently? And then do these two patterns always fire at the same time, right? Do they always match like the same events? And based on these sort of like statistical notions of which patterns tend to behave in certain ways, you might be able to develop a sense of like which things are especially unusual, and use that as sort of a ground for like what makes an interesting story, or what sort of is worth highlighting to the player. And then there's been some work on sort of cognitively grounded models of story understanding, like Indexter is one of those examples, that you can operationalize, and that might also be useful for developing sifting heuristics in the sense of like, using these cognitively grounded models of story perception to convince the system basically that the things that humans would find interesting in a story are the same as like the things that it would be like then able to detect and surface for whatever reason.
We
and the other
haven't talked about Indexter yet, but that's coming up not too far from now.
Nice. Yeah. No, I find that like to be a super exciting line of work. I think we ought to talk more about smashing the things together at some point.
Absolutely.
And yeah, the other thing that I've been working on a lot lately has been this incremental sifting idea of like, can we detect potentially storyful event sequences and surface them while they're still going on, instead of sort of waiting for them to be completed, basically. And this is a thing that I'm sort of going to have a new system out about pretty soon. I have a brief example past the end slide here, so we can maybe talk about that if people are curious. But this is relevant to sort of both the procedural generation of foreshadowing, so like trying to identify things that will happen in the future and then sort of like procedurally indicate, oh, here's some things that we think are going to play out later on. And then also to this mixed initiative sifting idea of like, can we sort of help players identify that like the seeds of stories, and then sort of tend to the seeds of stories and like garden them into the story that they're interested in telling, basically. And this also resembles the narrative promotion thing that The Sims 2 does, where they have a library of story trees, which look very similar to story sifting patterns. They detect incomplete matches against these story trees of events that have happened so far, and sort of bump up the probability of events happening in the simulation that advance these story trees in various ways. So you can use this to like basically make the simulation aware of like what stories the player might be interested in developing, and then sort of again promote like the events that advance these stories in various ways. So yeah, that's been sort of a brief overview of what's going on in story sifting. There's a bunch of papers that I've written about these that are all on my website, if you want to like sort of check out more details about any of these systems. And thank you. I'll take any questions now.
Thank you, Max. That was great. That was a really great summary of just of the paper we read, but also all the other places you have gone and will go with this, which is so exciting. Yeah, the first thing that came to mind, and maybe this is just exactly what you were talking about on the previous slide, is could you, like, say you had a sifting pattern that was 3 events and the first 2 have happened. Can you recognize that and say, hey, now's my chance to make event 3 happen according to the pattern? Is that what you were talking about on the previous?
Totally, yeah. Like literally, I think we have an example of that in like what we're doing with Winnow, which is the next system coming down the line.
Awesome. And my other question was sort of, do you see a role for like reinforcement learning involved in here? Like we've talked about this mixed initiative, like having the humans write and or refine the sifting patterns, but I wonder about, and the emergent systems that you're working with, that's the theme of the last like 4 or 5 papers that we've read, these sort of, many agents, emergent systems. And presumably in most of them, the agents are running like some pretty simple like state machines or some sort of reactive, like if X then Y logic. And presumably they're not doing a lot of like planning ahead or very complicated reasoning, because you sort of often can't afford to do that in those big emergent systems. So I wonder if you could use reinforcement learning to train the agents to produce higher quality stories, to like modify either the state machines that those agents are running on or whatever their underlying, relatively simple architecture is, like sort of train your agents to do more interesting stuff.
Yeah, I hadn't thought about that as a possibility at all, but it sounds really exciting. And yeah, I think one of the interesting things about story sifting is that once you've got this definition of like what a story is or what an interesting story is, you can start applying that in all kinds of like different unexpected directions.
What sort of architecture are you using for stuff like that? So like in, I don't know, maybe Bad News is a good example, or maybe the Cozy Mystery Construction Kit. Like so you've got the current state. How does an agent decide what to do in that state?
Yeah, right now what we've got is a pretty naive thing where they just basically match all of the possible actions they could take against preconditions, like in sort of a like, here's generate all the possible actions I could do sort of way, which is gated largely on like the existence of certain motivation tokens or like things the characters want to do. And then based on that, like filter down to, I think we have like sort of a scoring thing basically we do where we weight like the actions that are most relevant to the most motivations all at once, the most highly, basically. And then we sort of also add in the author goals there in sort of the mixed initiative context where like the players have picked out, I want to see these things happen in the story world. So we pull things to the front that are like, this satisfies what characters want to do, this satisfies what the players want to do. And we've got a few different definitions of both of those things. So we can sort of sort based on which ones are most frequent. And then we do sort of like a weighted random pull, I think, and show like the top 3 or 4 as options typically to the player.
That makes sense. So it is kind of a Markovian. I guess is it ever looking into the past, or is it only thinking about the current state?
It's only thinking about the current state, which actually includes a bunch of the past because we
Right.
commit all the events to the database as like logic statements or whatever. But yeah.
So it's, I don't know, Markovian asterisk, but
yeah.
But and so that's just the sort of thing where like, yeah, if you've got this like, okay, we've got all the actions we could take, then we sort of weight them and filter them, like adjusting those weights via like reinforcement learning or something is like, it seems like a really straightforward application for, just like run 1,000 worlds and reward agents when they happen to fit more sifting patterns.
Totally. And yeah, one of the things that I think would also be interesting to combine with that possibly is like, I've wanted for a long time now to do this kind of like role play oriented character authoring thing where you basically put characters into a bunch of situations and have the player choose like what they would do. And like, I don't know, that seems like it would be compatible with what you're talking about here.
Cool. Okay. Thoughts, questions? I know there were at least a couple of lingering questions about the space simulation game. Go ahead, y'all.
I had a question about like what's the upward bound on how complex a sifting pattern can be?
Yeah, we haven't like super stress tested the upper bound all that much, but the longest ones that we've written are things like, I think like 25 lines of felt, which is like, I don't know, I'd say that's matching like a sequence of like 5 or 6 events probably is my guess. And then like there's maybe a couple of not joined constraints dependent onto the end of that as well. In theory, you could do more than that. I think you'd start to see performance problems if you were like, well, actually, I don't know, because it would be worth testing like a really long sifting pattern and just seeing what happens.
Yeah, I guess I was just kind of thinking about like if somebody had a really particular story they wanted to frame their experience around.
Yeah, my hunch is that actually it would be in some ways less performance problem inducing if you have more and more specific sifting patterns, because the longer they get, the more specific they tend to be and the fewer possible matches they tend to have. So you're not like constantly considering and discarding a bunch of like potential matches, which is one of the things that you do with the simpler ones a lot.
I'm curious about we were sort of talking about, something that's hard to measure, at least in the planning-based systems that I work with, is these like meta properties of the story. And you've got that, just makes sense to, hey, compile a bunch of information about the past and stuff into the current state. But you don't have to do that, right? Like you could theoretically derive all that stuff as needed. Like character 1 has harmed character 2, and instead of recognizing all situations and compiling that into the state, you could just ask that question on the fly.
Mm-hmm.
I don't know if that would get super expensive. Like I'm thinking sort of Ian Horswell, like prologue style queries.
Yeah, no, one of the things that I'm actually interested in is to sort of mitigate the effects of the state blow up over time, like garbage collecting the state at certain intervals, for instance, or like sort of compacting it down to like, this is just the stuff that we care about being retained. We're going to discard like event sequences that are older than this, or like consolidate judgments into like consolidated judgment objects, as opposed to like retaining all the individual judgments that every character has made of every other along the way or whatever. I haven't really looked into this direction much because in practice we're sort of deliberately keeping our testing story worlds pretty small. Like there's like maybe, I don't know, 10 characters in a lot of these examples, and like they're not doing all that much. Like they're just like, we're in like the tens of thousands of events sort of like area, basically, not like super high numbers. But
and
if we
it's funny
start
to hear you
getting
say
into
that
like,
because like our planning based systems, like 5 agents and 10 events is a lot, so
but yeah, like when you're comparing it against like real like simulation games like Dwarf Fortress or whatever, like the numbers are huge in those contexts. And so there's things like Legends Viewer, for instance. I don't know if people are familiar with that, but like it's sort of a tool for viewing the history of Dwarf Fortress worlds, basically. And like Dwarf Fortress has like thousands or tens of thousands of characters, I would imagine, and like just so many events all over the place all the time. And trying to like apply this technology to that, I think you would start to run into performance problems that are pretty significant. And so one of the things that we've been thinking about is like, how do you like apply this to real story worlds of the contexts that are like the huge ones you see in Dwarf Fortress and Crusader Kings, stuff like that, basically. And so, yeah, I don't know. I think a lot of the same techniques apply fundamentally, but you need to start doing a lot of aggressive caching and a lot of like consolidation of state things to make it work.
I know we've got several tabletop role-playing game enthusiasts here. What are your thoughts for applying sifting, or just insights about, I don't know, how do you as humans do sifting? You experienced dungeon masters and tabletop role players out there.
I guess for the most part, I think players tend to do the sifting when I'm running games. And otherwise, I just kind of like let events kind of proceed to like the natural conclusion, I guess. And I kind of sift through like likely events, but I don't know. It's interesting because I think I'll be thinking about it in these terms a lot more now than I did before, which is interesting.
Do you ever collect? Do you ever ask players to like reflect on things, and are you ever surprised by the results? Like what they chose to highlight or remember?
Yeah, there's a lot of times where like I might plan a lot more, and they'll kind of sift through what I have planned and get through it a lot quicker. And then usually at the end of like a long period of story, I'll ask all the characters to reflect on like how they feel about the last like however many sessions, and that's usually when I get like the feedback of like what works for what character and what doesn't, which I guess is kind of like a way of reviewing how well I sifted through things. But
that's another application I hadn't even considered, like sifting patterns as a player model. You know, modeling the player as which sifting patterns they like to see versus don't care about seeing.
Yeah, that's interesting. I feel like, yeah, players as story perceiving agents is like another one of those interesting. Like we can apply some of the cognitively grounded stuff to that, and then also some of the story sifting work to that.
What about Ryan? Do you think something like this could apply to penumbral passage?
I mean, there's not really many narrative elements to that game. It's like the game I'm working on is traditional like European worker placement style board game, so it's not very narrative heavy. But there might be a way to think about it's procedurally generated, the board and stuff, so there might be a way to kind of apply some tangential logic there.
I mean, something like this could be just sort of like, I think I've even heard of people using Dwarf Fortress as a way to help generate the background to a tabletop role-playing game campaign. Something like this could allow you to create a sort of very rich kind of history for a role-playing game, which which there's going to be a lot that's not interesting, but the part that's you're able to sift out is going to be what you actually include in the background, I guess.
Totally. That actually reminds me a little bit too. One of the things that is currently happening in the Expressive Intelligence Studio, which is the lab that I'm in, not my work, but Shai's, is, what's his full name? Shai Bay Johnson, I think. He's one of the relatively new grad students. He's working on what we call like domain adaptation, basically, for story sifting, and like taking Talk of the Town and using it as like a backstory generator for other kinds of stories, like that aren't set in small American towns, for instance. And I feel like that kind of like recasting of characters, or that sort of like, I don't know, like taking an existing simulated story world, sifting down like what are the essential storylines in it, maybe, and then like translating that to a different domain is an interesting sort of like approach in and of itself.
Yeah, definitely. That's interesting.
One of the things that characterizes, I think, a lot of the, so I've done some work on retellings too, which is basically like players telling stories based on what's happened in these like digital game worlds of various kinds. So like especially in Dwarf Fortress, especially in like Stellaris and the other like Paradox games. And there's like this thing called Simlit too, where Sims players do a lot of this, sort of like using the game as like a narrative engine, basically, to generate material for their storytelling, and then like writing stories based on like what's happened and what they've sort of like tried to coax the system into doing, basically. The thing that sort of really stands out about a lot of those is that the systems that they're using have like these very defined textures to them. So like Dwarf Fortress stories have like a certain narrative grain to them, almost, of like they've all got the same sort of built-in narrative arc of like things start out relatively calm, build to a catastrophe, and then like rapidly disintegrate. And like that sort of narrative arc that sort of like is repeatedly stamped on the stories produced by a system, I guess, is one of the things that like players seek out when they try to tell stories using that system. And I think that like that sort of textural property of simulations is like not super well defined right now, but it's definitely core to why players use certain systems for storytelling and prefer certain systems for storytelling. And I feel like that kind of adaptation might be interesting for like getting the texture of a Dwarf Fortress story in like a Crusader Kings story or in a Sims story or something like that, or in different domains maybe.
Well, you mentioned Stellaris, and that's another one where a lot of what's to me most interesting in Stellaris is when you come on it's, if probably most people are familiar with it, but a lot of it is kind of a space exploration and resource management and things like that. But one of the more interesting things that happens in Stellaris is you'll come across like a planet that has a fallen civilization or something like that. But there are a limited number of those patterns. So you start to see the same kind of thing more often, and it's less interesting than the first time you saw it. But something like this could possibly create a more varied set of interesting kind of special events.
Or even just make it appear that way by highlighting and, choosing to feature different.
Yeah, exactly.
Yeah.
Mm-hmm. Right.
Yeah.
Which is really what I meant. It wouldn't necessarily have to be something that's genuinely unique. It would just be easier to sort of make it different enough that it doesn't seem that way.
Mm-hmm.
Yeah, you're just functionally like adding dressing with the system, right?
Yeah, something like that. Yeah.
I do think it's interesting to think about a system like this as like a developer tool to like marry it to these. If you're going to try to make something that's more of an artifact that's going to be, marketable. I talked about this kind of early in the semester, but like as like a brainstorming tool, like to supplement you as a creator.
Yeah, and a lot of the storytelling technology we've talked about so far in the class, you could not use in a commercial product unless it were built in from the beginning. This story sifting has the ability to potentially be used either as an analysis tool post hoc or even integrated into an existing system with, relatively painlessly.
Yeah, one of the things that I'm interested in doing actually is in using this for like analytics adjacent kind of work on story worlds, where you can like take different simulations, and if they're generating similar kinds of events, you can sort of like read the texture, I think, of simulations in an almost like an expressive range analysis kind of way by running like the same story sifting patterns over like the same kinds of events produced by different simulations, basically, and seeing like the relative frequency of those things, and then like I don't know what kinds of subplots happen a lot, basically. It's not a direction I've done much work in, but it would be interesting to like try and see to what extent do the simulations that people actually use have enough like sort of common structure between them that you can do that kind of meaningful comparison based on sifting.
Mm-hmm. Yeah, there's so many exciting places this could go. You have the problem of too many interesting, exciting problems to work on. That leads also to the idea I had sort of said, I wonder if you could use reinforcement learning to like change your agents to get them to produce better, more storyful content. But you could also even use it as like unit testing of one of these big, because testing these big emergent story worlds is so difficult by their very nature. And so if you had some other unrelated method of, modifying how your agents behave, you could even use story sifting as sort of like a, black box testing to sort of confirm that you're still producing good stories after whatever changes you make.
Totally, yeah. No, it would be really interesting to have like, I have this complicated story sifting pattern that has to be sort of fulfillable. And if I don't see it in this many generated events or whatever, then something has gone wrong and I need to fix my bugs or whatever.
Yeah, because I feel like, when authoring those relatively simple, like reactionary agents that are almost always used in these systems, you do it with these bigger patterns in mind, right? You do it with this like motivating event and then like response and then result sort of in mind. And so you could pretty easily phrase those as sifting patterns and then use those sifting patterns to confirm that those structures that you sort of had in mind do indeed play out. Great. Well, thank you so much, Max. I really appreciate you being here and sharing these insights and ideas with us. Good luck with the many, many exciting directions you could take this work. I'll be exciting to see which one or ones of them end up being the actual focus of your dissertation, but it sounds like you've got at least one career's worth of cool stuff to investigate.
Totally. And yeah, thanks again for having me.
Oh, thank you for being here. All right. Thanks, everyone. Let's have virtual applause for our guest speaker. And see everyone on Wednesday. Thanks again, Max.
Yep. See ya.
Thank you.